Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams.
Welcome to question 6, CSEC Math Exam January 2012 video solution. And the question gave us this function y equals x squared minus 2x minus 3. That's a quadratic function. And it gave us values in this table from x equals -2 up to x equals 4. Those are the integer x values. And we are asked in part A to complete the table, copy and complete the table. To complete the table, we basically need to put in the value for here, for this cell, and the value for here. Now in this cell, the x value is -1. So we need to substitute that -1 in this function equation. And that will give us the y value for here. And then at this cell, x is 2. So when we substitute 2 in this function equation, that will give us the y value for x equal 2. So let's go ahead and show all that calculation. Now we are copying and completing the table. And as I said, at x equals -1 for this cell, we substitute the -1 in this function equation. So it becomes -1 squared minus 2 times -1 minus 3. So that reduces to -1 squared is +1. -2 times -1 is 2, +2. And then this -3 comes back here. And we see that this works out to 0. 1 plus 2 is 3, minus 3 is 0. So that's the value of y for this cell, 0. And we can go ahead and show that value. And then for this cell, x is 2. So at x equals 2, we substitute the x value of 2 in the function equation here. So that's 2 squared, as shown here, minus 2 times 2, and then minus this 3. That's right here. And when we do that calculation, we end up with 4. 2 squared is 4, minus 2 times 2 is 4, and then minus 3. So 4 minus 4 is 0, and then minus 3. So 0 minus 3 is -3. So at that point here, at this cell, y should be -3. So we can place that. So that's our table completed, and that's the answer for part 1. Alright, now let's look at part 2. Part B. Part B says we are to use a scale of 2 centimeters to 1 unit on the x-axis. That's 2 centimeters to 1 unit on the x-axis, and 1 centimeter to 1 unit on the y-axis to plot the graph. This is a table that we carried forward. Alright, so what we want to basically do is plot these points on a graph. Alright, so based on the instruction, those will be the points. -2, 5, that's 1 point. -1, 0. 0, -3. 1, -4. 2, -3. 3, 0. And 4, 5. So these are the points we're going to plot. And based on the scale that is required, this is our grid. 2 centimeters is 1 unit. Let's say each of these grid lines represents 1 centimeter. Right? So 2 centimeters is 1 unit on the x-axis, and 1 centimeter is 1 unit on the y-axis. Alright, so that's the instruction. 2 centimeters to 1 unit on the x-axis, 1 centimeter to 1 unit on the y-axis. And we are now basically going to just plot all these points. And if we put those points in, that's what we have. -2, 5 for this one. -1, 0 for this one. 0, -3, that's for this one. 1, -4, that's for this. 2, -3 for this point. 3, 0 for this one. And 4, 5 for this one. So those are all the points. And all we need to do now is draw a smooth curve through those points. So that's the graph representing this function, right? And that's a quadratic graph. That's a parabola. That's a minimum turning point right here, right? So that's a parabola for this graph, a quadratic graph. And it's a minimum smile shape parabolic quadratic graph, right? And then now we're asked in part C of the question to find the y value, estimate from the graph the y value when x is 3.5. We have to do it from the graph, not by calculation. And we have to show on the graph how we carried out that estimation. We are not supposed to calculate it from the function. We are supposed to do it from the graph. So where on the graph is x equal to 3.5? That's right here. That's where x is 3.5. Alright? So we can mark 3.5 and then we have to go up on the graph. So that's where x is 3.5 on the graph, and then come across to find what the corresponding y value is. And that's the y value, right? That corresponds to an x value of 3.5. So let's show on the graph how we would construct that y value. So that's it. We would go up on the graph and then go across to the y-axis to see the y value, and there we can see the y value is approximately, or is 2.25, and that's what we would read from our graph, 2.25. So when x is 3.5 on the graph at this point is where x is 3.5, the y value is 2.25. So that's on the graph. X is 3.5 at this point on the graph, and the y value at that point is 2.25 as read from the graph. And that's the answer for that part. Y is 2.25. Now part D is asking us to use the graph again. No calculation required. Asking us to use the graph to write down firstly the equation of the axis of symmetry. What is the axis of symmetry? The axis of symmetry is a line of symmetry of the parabolic quadratic graph. This parabolic quadratic graph is symmetrical about a vertical line that passes through the vertex of the quadratic graph, or the minimum point, or the turning point. So the vertical line through this point here is the axis of symmetry, and that vertical line crosses the x-axis at 1. So therefore the axis of symmetry is the line which has an equation of x equal 1. It is the x value at the turning point on the graph, and we can show that axis of symmetry on the graph. That's it right here. That green line is the axis of symmetry, and the equation of this line, this vertical line which passes through 1 on the x-axis, is x equals 1, because x is equal to 1 at all points on this vertical line. So that's the answer. Our axis of symmetry is x equals 1. Next, we're asked to estimate the minimum value of the function, right? We want now the minimum value of y. Now the minimum value of y is the lowest y value on the graph, and that lowest y value on the graph is the y value at the vertex of the parabolic graph, or at the turning point. The y value at this point right here is the minimum y value. It's the lowest y value on the graph. The graph comes down here to -4. That's the lowest y value, -4, and then it goes back up. So this -4 here is the lowest y value on the graph. That's the y value at the minimum point on this smile shaped parabolic graph, right? And so the lowest, or the minimum y value, is -4 right at this point, right? And so that's the answer. Y min is -4. That's the answer for part 2 of section D. And then part 3 of section D is asking us to state the values for the solution of this equation. Now this is the quadratic equation associated with this quadratic function. And the solution of the quadratic equation gives us the roots of the quadratic equation. These are x values where the quadratic graph intersects the x-axis, because this really is the same as saying y is equal to 0, because x squared minus 2x minus 3 actually is y. So this equation is basically asking us where is y equal to 0, and y is equal to 0 on the x-axis. All points on the x-axis, y is equal to 0. In fact, the equation of the x-axis is y equals 0. Right? So on the graph, y is equal to 0 at this point and also at this point. And in fact, in the table we could see that y is 0 when x is negative 1, and also y is 0 when x is 3. And we can see that on the graph. X is 3 when y is 0 here, and x is negative 1 when y is 0 here. So therefore, these 2 points are the points representing the solution for this quadratic equation. Right? So we can highlight those 2 points, and at those 2 points, the x values that would therefore satisfy this quadratic equation would be x equals negative 1 for this point, and x equals 3 for this point. So those are the x values that would represent the solution for this quadratic equation, right? And that's the answer for question 6, right? And we'll look to do question 7 in our next video, right? So see you then.
You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.